3-Eye Atlas.
Alien technology.
Nuclear-powered spacecraft.
Comet, asteroid, or something else.
The interstellar object racing through the solar system is not behaving like a comet, an asteroid, or anything we've ever seen before. Its chemistry defies the rules, its path seems intentional, and its signals grow stranger by the week. Among astronomers, a bold hypothesis is now emerging. What if this is not random at all? What if this is the first sign of extraterrestrial contact? For decades, we've searched the skies for radio messages or engineered signals. But what if the message was never meant to be heard? It was meant to arrive. In the weeks since its discovery, telescopes have revealed a catalog of anomalies. Its coma, the shroud of gas and dust that surrounds the core, is dominated not by water, as in every other comet studied, but by carbon dioxide, with water making up a fraction so small it is barely measurable. Its surface glows with an unusual green hue, hinting at exotic organics and chemistry unseen in our own planetary system. Even stranger, spectrographs show the unmistakable presence of nickel without the usual companion element iron, a separation that should be impossible outside of an industrial process. And then there is its orbit, a trajectory almost perfectly aligned with the solar system's ecliptic plane, weaving past Mars, Venus, and Jupiter in sequence, as if tracing out a deliberate path. These are the broad strokes of the mystery, and they are troubling enough on their own. But beneath each headline finding lies a tangle of detail, observations that resist explanation and grow more bizarre with every new dataset. Astronomers have been quick to remind the public that extraordinary claims require extraordinary evidence. Yet when one anomaly stacks on top of another, the lines between natural possibility and something else begin to blur. The next few months, they say, will decide which side of that line 3-Eye Atlas falls upon. To appreciate how unusual this object is, it helps to remember how rare such visitors are. Interstellar objects are not supposed to be common. The distances between stars are so vast, and the odds of a random fragment being flung directly into our solar system so slim that for centuries astronomers never expected to see one in their lifetimes. That changed in 2017, when the first Oumuamua tumbled silently through our skies. It was small, faint, and moved too quickly for us to study in detail, but not before it revealed an unnerving quirk. It accelerated in ways gravity could not explain, with no visible jets or tail to account for the push. Debate raged over whether it was a shard of rock, an icy fragment, or even a discarded fragment of technology from some distant civilization. 2 years later came 2-Eye Borisov, which looked far more like an ordinary comet, spewing water vapor and dust as it swung around the sun. Its behavior reassured scientists. An interstellar visitor, yes, but one that fit the rules. 3-Eye Atlas is not offering that reassurance. From the beginning, it has looked neither predecessor, but something in between. It carries the chemical oddities of Oumuamua, but the bright activity of Borisov, scaled up to a size estimated between 20 and 40 kilometers across. Even before it drew near to the sun, images showed it glowing faintly, already shedding material while still out beyond Jupiter. Water ice cannot sublimate at those distances. The temperatures are far too low. Only highly volatile ices like carbon dioxide or carbon monoxide could account for such early brightening. That alone marked it as an outlier, but it was only the start. As the world's most advanced observatories turned their instruments toward it, the puzzle only deepened. The James Webb Space Telescope measured its outgassing at nearly 70 kilograms of carbon dioxide per second, compared with barely 5 kilograms of water, if any at all. That ratio, 16-1, is the reverse of what we expect from comets born in our solar system. In the cold nurseries where most comets form, water is the dominant ice, and carbon dioxide lingers only as a trace. To see the chemistry inverted so completely suggests a birthplace far from anything familiar, perhaps in a protoplanetary disk where temperatures never rose above the lowest extremes. That means this object is not just foreign, it is alien at the level of its chemistry, carrying the fingerprints of conditions that may not exist anywhere nearby. Polarimetric studies soon added another layer of strangeness. Normally, when sunlight reflects off a cloud of dust grains, it scatters in predictable patterns. Astronomers can measure this polarization, essentially the orientation of light waves, and every comet, asteroid, or dust cloud studied to date falls into a well-known range. But 3-Eye Atlas broke the mold entirely. Instead of matching the expected curve, it produced what scientists call a deep negative polarization. It results so unusual that teams initially assumed their instruments were malfunctioning. The suspicion was understandable. This simply shouldn't happen. Yet the readings held firm, confirmed across independent observatories. The implication was hard to ignore. The dust surrounding 3I Atlas was scattering light in ways no natural cloud of particles had ever had before, as if its grains were shaped, aligned, or composed in configurations outside the ordinary laws of cometary physics. If that wasn't enough, spectroscopy introduced an even more perplexing riddle. Astronomers detected clear signatures of nickel within the coma, the gas and dust envelopes surrounding the object. That in itself isn't shocking. Nickel is a common element in space. But what made the finding nearly impossible was what wasn't there: iron. In the cosmos, nickel and iron are inseparable partners. They are forged together in the furnaces of dying stars, scattered through space in supernova explosions, and found side by side in every meteorite, asteroid, and planetary core studied by humanity. To find nickel without iron defies the very processes that create heavy elements. On Earth, such separation can be achieved through deliberate industrial processing, like metallurgy or chemical refining. In nature, no mechanism is known that can leave nickel behind while stripping away iron. Some researchers floated exotic scenarios, perhaps an unusual stellar nursery or unknown chemical pathways in an alien protoplanetary disk. But none of the theories felt comfortable. Quietly, whispers of something engineered began creeping into the discussion. Individually, these anomalies might be written off: a bizarre chemical mix here, a peculiar scattering effect there, a metallic fingerprint that doesn't quite fit. But taken together, they begin to form a picture that stretches the limits of coincidence. And perhaps the most unsettling piece of the puzzle isn't chemical at all, it's orbital. Instead of plunging into the solar system at a random angle as interstellar objects usually do, 3I/Atlas is gliding almost perfectly along the ecliptic plane, the thin, flat disk where every planet from Mercury to Neptune traces its orbit. Statistically, this alignment is extraordinarily unlikely, bordering on absurd. Even more provocative is the way its path threads close to key worlds in sequence. First Mars in early October, then Venus, and later Jupiter in March of 2026. Each encounter happens to position 3I/Atlas within reach of spacecraft already stationed there, offering humanity multiple opportunities to study it up close. To some astronomers, it looks less like a random flyby and more like a deliberate tour. The next milestones in this trajectory could prove decisive. In early October, the object will sweep within 28 million kilometers of Mars. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter are preparing to turn their instruments toward it, trying to peer through its dense carbon dioxide coma to glimpse the hidden core. Even a blurry outline could answer the critical question: is the nucleus an irregular, rocky lump like an ordinary comet, or does it show symmetry or structure that hints at something more? Just weeks later, on October 29th, it will reach perihelion, the closest point to the Sun in its orbit. This is typically when comets are tested to their limits, when ice erupts into jets, when fragile bodies fragment, and when brightness peaks. If 3I/Atlas is concealing deeper surprises, perihelion may be the moment they erupt into view. After vanishing briefly behind the Sun, the object will re-emerge in December, giving Earth-based observatories one more chance to track its evolution. By March of 2026, it will pass near Jupiter, where NASA's Juno spacecraft could attempt a final observation. Originally scheduled to end its mission with a controlled dive into the gas giant, Juno may now receive an extension, tasked with one last pursuit. If it succeeds, humanity may capture an irreplaceable final glimpse before the interstellar traveler disappears into the void forever. The level of coordination is unprecedented. Earth's largest telescopes, Martian orbiters, and a probe at Jupiter are all being aligned on this single target.
Scientists rarely speak in such terms, but this campaign resembles a planetary-scale briefing, as if humanity is collectively preparing for an event rather than an observation. If the orbit were random, if the chemistry were ordinary, or if the dust behaved as expected, 3I/Atlas might be dismissed as just another frozen relic from a distant star. But none of those things are true. It glows with alien chemistry. Its dust scatters light in impossible ways. It carries nickel divorced from iron, and it traces a path through the solar system that looks less like chance and more like choreography. That is why some astronomers are beginning to use a word not typically found in the scientific lexicon: arrival. Arrival does not necessarily mean collision. It does not guarantee danger. It may mean revelation, a moment when the object unveils its true nature and forces us to confront what we have long suspected. Perhaps it is only a messenger, its message written not in words but in presence, reminding us that we are not alone. Or perhaps it is simply a relic, extraordinary in its strangeness but natural nonetheless, here to expand our understanding of what is possible. Whatever the answer, the countdown is already underway. October will bring the Mars flyby, followed by perihelion. December will return it to our skies. March 2026 may bring Juno's final glimpse. Each milestone will write a new chapter in a story whose ending we cannot yet see. And when 3I/Atlas finally makes its move, the world will be watching, because whether by coincidence or by design, it has become the most compelling object humanity has ever encountered.